Welcome to a tutorial on installing gem5 in the SST, the Structural Simulation Toolkit framework from Sandia National Lab. I'm going to assume that you've just installed CentOS 6.3 64-bit fresh installation with SST 2.3. So here if you look at my earlier video on installing SST 2.3, that's what we've just finished here. And now we're going to add gem5. So in order to do that, we're going to add a few more additional packages which are necessary. So I'm going to change into the home directory, and I've just got SST installed. So I'm going to run sudo yum install scons, swig, zlib-devel, subversion, and glibc-static. So these packages are necessary for gem5. So it'll be about 6 megabytes, not too bad of a download. And then the next commands, once those have finished, is we're going to update the LD library path. So let's run that. And then another variable that we can add is m5exe. So this variable is going to be the location of later on where the application we're going to run lives. So let's just clean up the bashrc because we've previously edited that. So I'm going to do gedit bashrc. Alright, so we can get rid of, this is our previous command. We're just going to clean that up. So I've got module add openmpi. This is CentOS and it needs to be told that MPI is available. And then export LD library path. This is what we just added, and that includes where gem5 is going to end up in its path. And then m5exe is the application we are eventually going to run in gem5. So we'll save that. And then we're going to run source to update those environment variables in the shell. Alright, so now we can get started installing gem5. I'm going to go into a directory I've previously created, and it has boost and SST in there, and we're going to add the gem5. So this is a branched copy of gem5. It's not the full version you'd find on the gem5.org website. It's been modified a little bit to fit into SST. So we'll extract it, and then we're going to go into that directory. Alright, so now I'm in the gem5 source for the simulator, and we're going to make a new link to the portals. Alright, so once that's done, we will build the gem5 kernel for x86. This is the only architecture that's supported right now is x86. Gem5 normally has other instruction set architectures available. Looks like it wasn't able to find x86 variables, but it's going to continue on anyways. Alright, so this process takes a little bit of time. Right now it's 3:25. We'll come back when this is finished up. Alright, so the gem5 kernel just finished our installation using scons, and now we're going to make a link of the directory, and then we're going to reconfigure SST. So we've previously, let me just show here. We've previously installed SST, but now we're going to reconfigure it to recognize that gem5 is available. So this time when we run configure, we're going to have an additional switch which says where gem5 is located. Alright, so once AutoGen has finished, our configure is going to include SST, boost, and now with gem5 and the location of where we compiled that kernel for x86. So as I mentioned in the first SST video, if there's any errors here, we would see those, CHL, we would see those in configure.log. That's where they would be recorded. So if there's any problems, then that's where to look. But since we didn't see any here in our conclusion of the configure, then we'll just continue on with make all. Alright, so this is going to run for a little while. We'll come back. It's 3:45 when it started. Alright, now that we've just finished the make all command, we're going to run make install again. And once make install finishes up, then we're just going to demonstrate that gem5 actually works with a executable that is included in SST. So I'm going to switch over to where the application lives, and we're going to compile it with the make. And then once make finishes, we'll just verify that the binary actually runs. So the keyword, there's a bunch of variables that it puts out here, but the main thing that we care about, we're running on the host, so these are all the parameters relevant to our host. But the important thing here is goodbye Mike, indicating that the program finished successfully. So now we're going to go over to the place where the XML files live. These are the configuration for what gets run in SST. We're going to call the SST executable here, and we're going to pass it the SDL file, the XML file here, and we're going to specify the library path. So again, the same program that we previously ran, hello, just ran, and it finished with goodbye Mike, and that's SST finishing. The reason this ran is because we specified in bashrc the environment variable m5exe. So we're going to take a look at the bashrc just to remind ourselves where this is happening. So export m5exe means that we have the m5exe variable. exe. So this is saying where the program binary is, and then SST knows to run that. So this demonstrates that SST is installed and gem5, the component CPU simulator, works.